All right, so first thing I want to do here, if I'm going to use synthetic division, the first thing I want to do if I'm using synthetic division. Yes. So first I need to find the number that's going to go in this little box over here, which means I'm going to take the x minus 3, the little part, and set it equal to 0 so that I can solve for x. What do I need to do this now to solve for x? Add 3 to both sides, yes. So I have x equals 3, so 3 is what I put up in this little box. How do I get the other numbers that are going to go here? Yes, bring them down from the other polynomial. So 3 is the first thing I bring down. That's the exponent on x cubed. And then I need to drop a degree for each of the other exponents. So x cubed, and then I need the exponent on, or sorry, the coefficient on x squared. What's the coefficient on x squared? -7. All right, so x cubed, x squared. Now I need the coefficient on just x, -11. And finally, I need my constant, 15. So just for reference, this is my x cubed. This is my x squared. This is x, and this is my constant. I do an equal sign with a little leg off to one side. Sometimes I'll even give myself a little dashed line right here so that I know I've just sectioned off just that one last number there. What is the first thing that I do? Bring down that 3. First number comes straight down. Okay, so I got that number down there. What do I do next? Multiply the 3 that's here. And where do I put the answer? Right underneath that -7. So 3 times 3 gives me 9. That goes underneath the -7, and I'm going to add those together. What do I get when I add those two together? Two. And I'm not sure if anybody else said that. I heard like little whispers, but I couldn't hear any numbers. So I apologize if you said it and I didn't hear you. What do I do next? 3 times 2. What is 3 times 2? 6. I write that down right here and I add it to the number up above. -5. What next? Yep. 3 times -5. So I have -15, which I add to the value up above. And I get what? 0. What do I call that 0? That is my remainder. All right, so the directions said use synthetic division to write an equivalent expression for this division problem. So I have these numbers down below, 3, 2, and -5. What do I put with this 3? X squared. It had been an x cubed. After I do this synthetic division, it drops a degree. So 3x squared. What about with this 2? 2x. Positive or negative? Positive. So plus 2x. And then my -5? Yep, -5. This is my new constant. Since there was no remainder, I leave it just like this. That right there would get you full points on the test. Now, on the test, you can potentially earn extra credit. If you take that answer right there, only when we have a remainder of 0. If you have a remainder of 0, and you factor this to find the other roots, you can earn extra credit there. So again, if you stop right there with that black box, that's fine. You get full points. You don't lose any points. It's not like you missed doing something. But if you take it an extra step, I will give you extra credit for that. So if I take 3x squared plus 2x minus 5, and I decide I'm going to go after those extra points. So I need an area model, a box, and I'm going to need an x. What would we put here? Our a value. What is our a value? 3x squared. What do I put down here? -5. We put our c value down here. How do we decide what's going here and here? This is where the x comes in. So to use the x, first I multiply the coefficients for a and c together. So what numbers am I multiplying? 3 times -5, which would give me -15. So multiplies to give me -15, adds to my b value. What's our b value? 2. What multiplies to -15 but adds to 2? I heard 3 and 5, because that's going to multiply to 15. -3. Since the 2 is positive, the bigger number has to be positive. So -3, +5. What do I need to make sure goes on it when I put it in the box? An x. -3x, +5x. And then we start looking at this 2 boxes at a time. What do 3x squared and 5x have in common? They have an x in common. What about -3x and -5? Well, I can't take 15 out of 3. 1. Positive or -1? Negative. It's touching a box with a negative sign, so I take that negative out with it. So x minus 1 is one of my factors. And then I'm going to go the other direction. So vertically this time. What's the biggest thing I can take out of 3x squared and -3x? 3x is absolutely correct, sir. What about 5x and -5? What can I take out of both of those? I can take a 5 out. Will that be a positive or a -5? Positive, because it's touching a positive box. So 3x plus 5. Getting this far with the factoring will earn you extra credit. You can earn even more extra credit by doing what with each of those factors? Set them equal to 0. X minus 1 equals 0. 3x plus 5 equals 0. How do I solve this first one for x? Add 1 to both sides. So x equals 1. What about this one? What do I do to solve that one for x? -5 on both sides. And then we divide it, yes. Whenever I see a number and a variable smashed together, those are being multiplied. And so then I use division to make that cancel. I can't simplify -5 over 3 anymore, so I just leave it as -5 over 3. So there were 3 roots here. This is one of them. This is one of them. Where's the third one? Yep, this guy up here was the third one. So getting it to right here gets you full points on the test. Taking it to here earns you extra credit. Taking it one more step after that earns you even more extra credit. So you guys have the opportunity for quite a bit of extra credit on a question like this. All right. Let's look at your review. We did the whole front page yesterday, right? 1, 2, 3. We just did 1 and 3. Okay. I knew we didn't have a lot of time in class. I couldn't remember exactly because I did 1, 2, and 3 between all of my Algebra 2 classes. Huh? Yes, I did it in Zoom. That's why you were told there was a required Zoom. That's why it was up on the board too, even though I wasn't here. We're required by the state yesterday that you guys had to attend, and if you did not go to your Zooms, you will get counted absent. Yeah. I like how you brought that out second. All right, let's actually, are you guys okay if we start on the back side of the front page? Okay, because we did 1 and 3 together. Number 2 is almost exactly like number 1. So I really want you guys to try that one on your own to make sure that you can do all those pieces. All right. For this one, on all 6 of these parts, we are supposed to identify these using the most descriptive term, and they give us a list to choose from. Polynomial is one of the choices. Quadratic, linear, or none of these. So on all of these, even though it's not there, they didn't write it, it is understood that there's an equals y, or equals our function notation. So even though they didn't put it there, this is all equal to something. These are all function rules here. Looking at this first one, if we were to graph y equals 2, what would that look like? Y equals 2, that's what that first one is, because it's going to be a straight line. Y equals 2 would be a horizontal straight line. If it just has a y equals and there's no x's at all, that means it goes through the y-axis, but it doesn't ever touch the x-axis. That's how I know it's a horizontal line. So what would be the most descriptive term for this type of function? Would we call this a polynomial, a quadratic, a linear, or none of these? Linear. What about the next one down? 1/2 t plus 4. Polynomial, quadratic, linear, or none of these? It is a polynomial, but is that the most descriptive? What would it look like if you graphed it? What's a quadratic look like? A parabola. What kind of exponent do you have to have if it's going to make a parabola? Squared. In order to have a quadratic, we need a squared variable. Do we have a squared variable on part B? Okay, so it can't be a quadratic. This is linear. It is. Let's talk about it. They didn't use the variable x, they used the variable t, but does it have a slope and does it have a y-intercept? Yes. What is our slope here? 1/2 is the slope. So where's our y-intercept? It's this piece right here. If it has a slope and a y-intercept, it is a linear function. It does not matter whether the variable they use is x or something else. In this case, they chose t. Maybe it means time. Maybe it's a story problem where it's time and height. And so they decided to use h and t instead of x and y. That is totally okay. But what we're looking for with linear functions is that it has a single variable in the expression. So I'm not looking at that equals y part. I'm looking at just what they printed on the page. There's only one variable, and it does not have an exponent on it. Or if it is, It's just a power of 1, which is the same thing as not writing down the exponent at all. That is going to give me a linear function. What about part C? Do we have a squared variable? Do we have a squared variable on part C? No, we have a square root, which is literally the exact opposite of something that's been squared. It is none of these.
So what is quadratic?
Quadratic, you have to have a squared variable, not a square root, but a squared. So you need to see a 2 as your exponent. That will be the biggest exponent of all of them. So this guy right here, whenever I see a root or a radical, that is the same thing as a fractional exponent. This means the same thing as x plus 4 to the 1/2 power. A quick note for us. Polynomials no roots or radicals. Around variables. No negative exponents. In order to qualify as a polynomial, only positive whole number exponents. Roots and radicals, those are fractional exponents. No negative exponents. This means no variables in the denominator. So things that I'm looking for that would immediately disqualify it from being a polynomial. If I see a square root and there's a variable underneath it, it cannot be a polynomial. If it's not a polynomial, it can't be a linear or a quadratic, because those are special types of polynomials. The other thing I'm looking for is if there is a denominator, there are no variables down in my denominator. If there are variables in the denominator and it's been fully simplified, it cannot be a polynomial anymore. I can have fractions where I just have numbers down in the denominator, like that 1/2 t. The 1/2 was not a problem. If it was 1/t, that would be a problem. All right. What about D? What do you guys think on D? We do have a squared variable, but with a quadratic, the biggest exponent has to be squared. This is a polynomial. This would be considered a 5th degree polynomial because the biggest exponent is a 5 here. Yes. Shadrach just asked if that would make F a quadratic, and the answer is absolutely affirmative. This one is quadratic. The biggest exponent is a 2. So what about E? Why is it none of these? Has a variable in the denominator. It can't be simplified any further than it already is, and there's a variable in the denominator. So this guy right here is why it is not a polynomial. So again, variables in denominators, variables underneath radicals. If you see either one of those, it is not a polynomial. So far, so good? Do you guys want to look at number 5 next? All right, let's go look at number 5. I do not need to look at the entire polynomial to be able to do this. If I look just at the variable that has the biggest exponent, I'm going to be able to tell which graph this matches. What are the two parts that I want to pay attention to here? Inside that green box, I'm looking at two very specific things. If it's negative or positive, and the exponent. So this right here, what does this tell me about? Yeah, this one tells me that my n's are what? That's not what that one tells me. What type of a number is 3? It's an odd. It is positive, but it's an odd number. What does that tell me about my n's? They go opposite. N's are opposites. Because it is odd. So I can narrow it down to which two? A and D. How do I decide whether it's A or D now? What'd you say, Shedrick? Nope. We're going to do everything right here with just that leading piece. What was the other thing that you told me we needed to look at? Not just the exponent, but what else? The exponent tells me about the n's. The coefficient. Tell me about that coefficient. Shut it off, please. It is negative. What does that leading coefficient tell me about? What's going down? It always tells me about the right side. Leading coefficient always tells me about the right side, never any other. This tells me that the right side goes down. So which graph has the n's going opposite directions and the right side going down? D. All right. I realize I'm moving to C before I go over to the other column, but are you guys okay if I just move down right below this one? I'm still going to look in the exact same spot. I'm only looking at the x with the biggest exponent on it. What is my exponent here? 4. Why do I care about that? What information does it give me? It's even. Yes, my n's go the same way because it is even, which means I can narrow it down to which two? B or C. How am I going to narrow it down further than that? Leading coefficient right here. It's positive. So this tells me what? Right side goes up. So that means it goes with which graph? Graph B. All right. Top of the next column. Where am I looking? What's the only thing I care about? Exponent. Which one? I see two of them. Highest one, so I'm looking here. What does that tell me? Yep. Ends are opposites. Because it is odd. Now there's no saying that I can't have two graphs that match with, or like one graph that matches with two equations. Coefficient is positive. Right side goes up, yes. So which one? It is A. And then what do I want to pay attention to on the next one? What are the pieces that I need in order to be able to answer the question? What do I need? It is even. Do I look at the coefficient for that one? No. Exponent, yes. This is even, so what does that tell me? Ends go the same direction. Because it is even. And then how do I know for sure that this has to go with C and not B? Negative leading coefficient, so the right side goes down. So this matches with graph C. All right. Do you guys have any questions on this one for me?
Oh, yes.
Yes, sir.
So if the coefficient is on, like, say, but you still use exponent.
You will only use the coefficient that is attached to the x with the biggest exponent. You will never go looking for a different coefficient. So whichever piece you identified as having the biggest exponent, all your information that you need comes from there.
That one number. I mean, yeah.
That one term will give you all your information. The exponent tells you about the ends, whether it's same or opposite. The leading coefficient only tells you about the right side. Guys, please, please, please do whatever it is that you need to do to remember that that leading coefficient will never give you information about the other side. Always right. Always the right side. All right. Let's go to number 6. Let's just kind of keep marching through here. What do they want me to do on this problem? It says simplify. And what's happening between these two polynomials? Subtraction. When I'm looking at a subtraction problem, what's the first thing I need to do then? Distribute. So I'm going to distribute that negative to each of these pieces here. So I'm going to have a negative 3x to the 4th plus 10x cubed minus 2x squared plus 6x minus 3. I only distribute to what comes behind the subtraction because I'm subtracting all the things that come after it. What do I do with that first polynomial? First polynomial, everything just stays the same. It's the same as if I multiplied it all by a positive 1. Everything here stays the same. 7x to the 4th minus 3x cubed plus 11x squared plus 14x minus 3. We've got two different methods that we can use here. We can either use the horizontal method or we can do the vertical method. Which way do you guys prefer? Vertical. So when I go to use the vertical method, I'm going to take this first polynomial here, and I'm going to recopy it exactly as I see it. And then I'm going to come over to this second polynomial. And I'm going to write it underneath the first one. Making sure to line up my like terms here. And then I'm going to just combine like things. So here I have my x to the fourth, 7x to the fourth minus 3x to the fourth. What do I get when I combine those? 4x to the fourth. And then I come over here and I do the same thing to my x cubes, negative 3x cubed plus 10x cubed. 7x cubed. Positive or negative 7x cubed? Positive. Then we're going to come over to the x squareds. I have 11 minus 2. 9. Positive or negative 9? Positive, because I have 11 minus 2. 14x and 6x. What do I get when I combine those two together? 20x plus or minus 20x? Plus. Anything else to combine? Negative 3 and negative 3. What happens when I combine those? Negative 6. What would give me a 0? If it was negative 3 and positive 3. But I have negative 3 and another negative 3. So this would be my final answer here. Yep, negative 3 minus 3 more. All right. Let's turn the page. I want to look at this guy with the table. We're going to figure out how to get the answers from just the table. And then I want to show you the graphs that we can check our answers. Okay. Now, when you guys go to take the test on Friday, you won't have the opportunity for a graph if I give you a table. So I want to make sure that we're focused on that skill right now. How can I tell where the zeros are going to be located if I don't see a 0 down that f of x side? What am I looking to happen? How will I know where my zeros occurred? That gives me my y-intercept. I want to use the table. What am I looking for on the table? Yes, where it switches from being a positive to negative, or it switches from being negative to positive, where it changes signs. Because if I'm connecting those dots, if I connect a positive with a negative, I have to cross the x-axis somewhere in between there. Where's the first place that you see that it switches signs? Negative 25 and 2. What are the x values that it's going to fall in between? Negative 2 and negative 1. So between negative 2 and negative 1. You with me? Okay. Anywhere else? Yeah, I have negative 4 and positive 23. It switches again. So that's going to be in between what x's? In between 1 and 2. All right. Maximums. What's a maximum? highest point. So what's a relative maximum? A relative maximum is any kind of bump, right? It's going to be like a hilltop. Yes, ma'am. Wouldn't it what? In between 2 and -1. So like in between these guys? Oh. Yes. Because we changed sign again there. Thank you. So we're also going to cross in between these. So in between -1 and 0. Let's add that in up here. So between -2, -1, -1, 0, and 1 and 2. Thank you for catching that. I scooted on to the next piece too soon. All right. Relative maximums, bumps. I'm going to see a relative maximum if I'm looking at the table and it's getting bigger, getting bigger, getting bigger, and then it starts to get smaller because then it's going to have turned and go down. So from -25 to 2, is that getting bigger or smaller as I go from -25 to 2? Bigger. And then when I go from 2 to -1, have I gotten bigger or smaller? Smaller. So I was getting bigger, and now it's turned and it's getting smaller. So somewhere right in here, there is a relative maximum. So it is near x equals -1. I don't know where exactly, but if I look on the x-axis and I'm over by that -1, I'm going to see it having turned over there. If I'm going up, so I'm looking down that f of x column, is -25 very high or very low? It's pretty low. And then it goes up to 2, so I traveled up. And then what happened after that? It went down to -1, so it had to get up to get to the 2, and then it had to have turned because it's going back down. So if I'm looking for that high point, I'm looking in between those. Like it went up and then it went down. So I'm looking for where it made that turn. Does that make a little bit more sense? Okay. Relative minimums. What is a minimum? Minimum is the lowest point. A relative minimum is going to be like a valley. It's not necessarily the lowest, but compared to the other things it's around, it's going to be a low point. So what I would be looking for on this table, as I look down the table, it gets smaller and smaller and smaller. And then all of a sudden, the next number is bigger. So it had to have turned around at that point. So let's pick up where we left off. We said that we had a relative maximum right here. And then it got smaller, right? Down to -1. What happens after that? It keeps getting smaller, so we went even lower. What happens after that? It started going up. So it had to have turned right here. That's the smallest, the lowest that I see anywhere right around it, because after that, it made a change in direction, not necessarily in sign, but it made a change in direction. So this is my relative minimum. It's near what on the x-axis? Near x equals 1. I'm going to pull up Desmos. We're going to look at this graph because I want to see if what we wrote here actually makes sense with what we see on the graph. So this is x to the 5th minus 4x minus 1. So I'm going to type that in right here. X to the 5th minus 4x minus 1. How many times does it cross the x-axis? 3 times. We said it's supposed to happen in between what numbers? Look at your paper. It's supposed to happen. Look up at that very first line. No, the line that we answered the question on. In between -2 and 1, that's this guy right here. In between -1 and 0, that would be this one right here. And in between 1 and 2, that would be over here. Where did we say our relative maximum was near? -1 on the x-axis. Here's -1 on the x-axis. You see how that maximum is really close to that? It's not quite at -1. It's a little bit further this way. But it's really near -1 on my x-axis. What about our relative minimum? We said it was near +1. Here's +1. That's really close to where my low point is there. So far, so good? All right. Let's see, because we've got less than 10 minutes before your study time begins. Why don't we go do number 9? We'll save number 8 for tomorrow because number 8 has 2 parts and it's kind of long, so we'll save that one for tomorrow. But we have time to do number 9 right now. What are they asking me to do here? I'm supposed to simplify. How do I do that? Should I use long division? Should I use synthetic division? Or should I do something else? So if we do synthetic division, I see 2 problems. The squared. I'm not allowed to use synthetic division if it has a squared. There's something else that I notice about this piece. How many terms does it have? 1. What do we call something that has just 1 term? Monomial. You can choose to do this with long division if you want to. I think there's an easier way. What about if I wrote this, still meaning division, but I wrote this slightly differently? How would this look as a fraction? Which piece would go on top? Which piece would go on bottom? The first one would go up on top, so 81 x to the 8th plus 36 x to the 5th minus 27 x squared would go on top. And what would go on the bottom? 3x squared. If I write it like that, does anybody remember how we handle this? What property can I make use of here? Distributive property. I'm going to distribute this monomial to each term in my numerator. So I have 81 x to the 8th over 3x squared plus 36 x to the 5th over 3x squared minus 27x squared over 3x squared. How do I simplify this first piece? We're going to divide the number part first. So what do I get when I take 81 and I divide it by 3? 27. How do I simplify the variable part? We subtract, because remember when I wrote them all out, we're going to cancel them. So I would take them away. So this is going to be x to the what? X to the 6th. Bring down my plus sign, and we're going to do it all over again now. First, I simplify the numbers. 36 divided by 3, 12. And then I simplify my variables. X to the 5th divided by x squared. X cubed, x to the 3rd. Bring down my subtraction, and we'll do this one more time. Numbers first, 27 divided by 3, 9. And my x's cancel out entirely. And so this would be my final answer. After bell work tomorrow, we will start with number 8, and then we'll do that last page, 10, 11, 12. That means that the only problem that we will most likely not do together is number 2. I want you guys to make sure that you do that one, but that would be the only one that you're expected to do completely on your own. When's the test? Friday. So we have tomorrow in class to study. Friday, you'll take your test. What do you guys have to do when you walk in the door before I'll hand you a test? Phones. They either need to be up on my desk, I'll have a basket for them, or they can go over there on that cart. There will be a basket over there as well, but you cannot have your phone with you at any point in time while there is still a test in front of you. All right.